Hi, and welcome to our React Training 101. I'm your host for today, Maarten. I've been a front-end developer for over 10 years now, and next to that, I'm a father of two little daughters, and I'm a sailor. I work at this.labs, and you can find me on twitter.com/Maarten Bicknese. So, what we're going to do today is learn everything there is to know about React and get started. We're going to do a small introduction, like what is React, how are you going to use React, and other things. Then we're going to jump into building React components, learning more about hooks, how you handle events like clicks and user input, before we move on to component architecture, routing, application state, and finally we're going to do some testing for our application. Let's get started with our introduction. So what is React actually? React is a framework, or maybe even a library, that helps you build web applications using JavaScript. And what makes React so unique is that it is small in a big way. It is a very small library that does very little in that sense, but achieves a lot in creating web applications and creating interactivity for your end users. And it does that through components, which you can build. And components can be small and simple, like a button, and they can be large and complex, like a whole login page. And what you would typically see is that a login page, a big component, is built up by smaller components like input fields and buttons. And another reason to pick React in this day and age is because it's a very mature framework. It's been around for a long time, and there's a lot of libraries out there to support you in building the UI or helping you fetch data. So there's a lot of stuff going on, and it's been picked up by a lot of developers. So it's a good choice. And we're going to have a quick peek at components here. So we know HTML, and we have written HTML elements like input fields or divs, and components look the same way. So what we have here is a feedback form that includes a normal text area, which we have from HTML. And then we have our give feedback button with a little text in it. And this way of building your web application helps you a lot. We can see the elements we have, we can register properties on them, and we can mix and match with the HTML elements already in place. What you've seen is JSX, which means HTML inside of JavaScript. And it's very simple. We have our constant variable definition for an element, which is this piece of HTML. It's a h1 tag with the text hello. What we can also do is pass in props or properties. And with that way, we can make our element or component a bit more dynamic. So instead of just saying hello, we can pass in a name. So now we'll say hello Maarten, or anonymous if there's no name at all. This concludes the first section, and we're going to move on to the React Components full on element module. In this module, we're going to dive deeper into the concept of React components. React components are the base building block of React. And we're going to talk about what props are and how to use them. We're going to do conditionals, so we're going to have different outputs from the same component. We're going to go into children, so passing other components into components. And lastly, we're going to talk about a bit of loops. While we're doing this, we're going to go over some tips and tricks and caveats you can use to build your React application. So let's talk about what components are. We've touched a bit on JSX and components in our previous module, and I'd love to go deeper into the whole concept because it's a core thing to understand within React how components work. And if it doesn't make sense how a function from React turns into JSX, it's going to be hard to follow all the other modules we'll have after this. So let's have a look at our top level comment here, where it says props, which is an object with string key value pairs, turns into JSX, and JSX is HTML in JavaScript. So we're gonna give something, props, to this function, and then we're gonna get HTML back. So if we look at the middle section here, we have a sample component written, and we call this component my component, and it takes a name as prop. And if we don't pass it, we're gonna use anonymous as a default value. This works in normal JavaScript just as well as it does in React. And as the return value, we're going to return HTML or JSX because it's written inside of JavaScript. And it's rendering the h1 element, which says hello, the name that has been passed to this component. And on the last line of this slide, we'll see the actual implementation, how this component gets used. We have my component. And as you can see, the prop gets passed as an attribute. So we have the attribute name with the value Maarten. And this will output h1, hello Maarten. And that's how components work in general. It's good to know that components are pure functions. So for the same props passed, it will always render the same HTML. But it doesn't mean that we can't have conditionals. So different props passed can go to different paths as long as they still output the same HTML every time. And we can see that here. We still have our component, which takes a name property. And if that name happens to be my name, Maarten, it will say, oh hi Maarten. And otherwise, it will say, hello, and the name that has been passed. So with the implementation we see at the bottom, it will render, oh hi Maarten. And if we wouldn't pass any attribute, if we would just render the my component as is, it would render, hello anonymous. And then we're going to move on to a special prop called children, which is a very powerful tool to use within React, and you'll see it used all over the place. It's one of the props that get passed, but you don't pass it as an attribute like we've seen before. Instead, if you look at the last line of this slide, you'll see it's actually passed as the body of an element. We have our my component element, which includes even more HTML and some text. And then in the middle section, you'll see children is just a prop as all other props are, and it gets passed to our function. We still render the h1 element and it's saying hello, and then we render children, which will in this implementation render audience as bold or within the B elements. We can pass anything as children in here as long as it's valid HTML, and we can even use other components we've written ourselves before. In this last part of this chapter, we're going to go over loops. So again, we have our my component element, or component. It's hard to say my component, and it takes a books property. It renders a unordered list, and in there it maps over all the books we've passed. So books needs to be an array, and then for each book it will render a list item with the book's title. If you can see here in the middle, it also takes a key attribute on the list item. This is not a normal HTML attribute, it's part of React itself. React uses this ID, or key, to keep track of which part of the HTML belongs to which book. So if the book moves within the list, it will still know that that part of the HTML matches that book. And that's very important for optimization purposes, as well as making sure an item doesn't get rendered multiple times within your same list. At the end of the slide, we'll see again the implementation, where we have the my component, which takes the books attribute, and we do the braces again. Or actually, come to think of it, we haven't used the braces just yet. So normally we'd used the quotes to send a string value as a prop. This time we're actually using braces. And that means that whatever is in our attribute is JavaScript. And what we're doing here is creating a new array. So we have our square bracket open for an array syntax, and within that is an object with the ID of 1 and the title of our book, my favorite book, The Hitchhiker's Guide to the Galaxy. I hope you have enjoyed this module, and I'll see you in the next one. In this module, we'll be going into hooks. In the past module, we went into creating our React components, and hooks allow us to make more complex components. So what are they? Hooks are functions that hook into React, as the name suggested. And with that, we can add more complex logic, we can make a more complex flow, and they really tie into React's rendering system, React's feedback loop, and therefore allowing us to do things, for example, when the component mounts or when it unmounts or when there are new props. And it's very good to know that hooks are tied to their closure, to their component. So if I'm using one hook in one component and the same hook in another component, they'll be separate from each other. They'll be in their own silo, they won't be communicating with each other, and whatever data is in the left hand side in the one component will also be, won't be in the right hand side. So that's a good distinction to start off with. And hooks allow you, for example, to store data, just like I said, and that might not fit with your mental model of how pure components work, because we have props in, and for each same prop we get the same output. But hooks are a little bit different, and I will try to demonstrate how that works. So if we look at our top right component here, is it my component with hook? It still receives my prop, so one of the props, and it uses a hook which gives a result. That result can be rendered in our JSX, so therefore it could be a different result from different props, or the same result for the same prop. So if my prop is Maarten, my name, and the hook result changes from each time we call it, it would render a different component or different JSX for each time we call it with the same prop. If we look at how props work under the hood, which is demonstrated in the bottom right, you'll see that it's not really how that works, because the hook result, what React does is cache that result or bind that to our component, and basically it makes a function that my prop returns a new function that takes the hook result that then gets fed into our JSX. So in that way, it's actually still a pure function, which with the same inputs will still render the same JSX or HTML. And we'll start out with our useState component. This is the one I mentioned before. This will help you store data within your component. And we have a little counter component here, which has a local state, the current count, which we'll see on the first line of our component. So we have the counter definition, which is a function which has no props, which is also possible. And then we'll create a count and set count function. It might, one second, sorry about that. So let's focus on the useState function here. It's all hooks start out with the use keyword. So if you see useState, but there's also useEffect and use memo or anything that starts with use, you'll know it's a hook. And useState gets called with the value 0. And that means in this case that we want a initial state of 0. It can be changed later on, but it starts out with 0. So then we're going to look at what it returns. And useState returns a tuple, which means it's an array with a set amount of values where the position in the array matters as well. The first item of the array is the current value of the state, and the second item in the array is the setter, which we can use to change our current state. Directly modifying count here will not cause a re-render of our component, and therefore we won't see the results. We use the setter to change the value, tell React the value has been changed, and React will re-render our component, and just our component, with the new value in it. So with that out of the way, let's look at the return value here, which is a div, a paragraph which tells us how many times our button has been clicked, and a button with an onClick handler that will call our set count with the current value plus 1. So each time we click the button, it will call our setter with the new value. It will be set, React will know the value has been changed, re-render the component with the new count, and it will update. And there's the little magic here is by calling set count, React will store the new value in the background, and useState, which is bound to our component, will not use 0, the initial state. It will actually use the value that it has been stored by React in the background, and therefore render you've clicked 1 time, 2 times, 3 times, and so forth for each time clicked. We'll move on to useEffect. And useEffect is for side effects that are a couple of options. And we have our main rendering loop, so we'll get our props in and give JSX back. But useEffect is for doing effects or side effects that are required for a component. This can be data fetching, this can be reacting to prop changes, this can be responding to component lifecycle events like mounting or unmounting. So let's have a look at how useEffect is used. We have a to-do list component here, and this time it takes a prop, it takes the list ID. And we have a useState again. This time we instantiate it with an empty array, and we're gonna fill it up with more list items later on. Now we can go into our useEffect. We can skip the initial syntax right now for the 2 functions, and we can go to the result, which is await get items for list. This is a function that gets some to-do items from somewhere. It could be an API code, it could be local storage. It doesn't really matter for this example here. All we need to know is that it's an async operation, and it's going to return an array of to-do items. So what we do here is we await this result, we wait for all our to-do items to be loaded, and then we call our state setter set items with this new result. And in the end, we render our checklist component, which is probably just a component that renders a list with our new items. So what happened on a global scale, what happens here is the first render, the useEffect is triggered, but it's not finished yet. It's an async operation, so it will run in the background. But React will render our checklist component with an empty array. That component might show something like there's no items. It might show an empty list. We don't know. It doesn't really matter. And as soon as our effect finishes, so the items are loaded and it calls to set items, the setter will again tell React something has changed, our state has changed, and it will need a re-render. So the component gets rendered again. This time it loads the new state with the new results in there, and it knows that useEffect has already been run and it doesn't need to run again. So we'll skip all of that. We render our checklist component again, but now with our new items in there, So it will actually show a list of items to do. There are two things we need to still go over here, and that is our function notation. So if we look at the use effect, which opens with a normal function opening, if you want to do anything that's not async, so just normal side effects, you can do it straight into that function. But if you want to do async operations, you'll need to make a new function, an async function, and call that to do the async operations. This is important because useEffects needs to close directly after being called, so then they need to be synchronous. If it isn't synchronous, if you pass an async function to useEffect, React doesn't know how to handle it properly and it might crash. So we'll advise you to use this setup. The second part I want to talk about is our array argument. That is the second argument of useEffect. In this case, it has a list ID in there, so our prop. And that tells React that it only needs to do the effect again whenever anything in that array changes. This gives us fine-grained control over when effects should be triggered or when we want to rerun them. And then for our to-do list, it's very important that it would fetch new items if we have a new list ID. So if we want to show, if we have multiple to-do lists, one for chores in our home and one for things to do at work, we could switch the list ID between these two lists, and React will know that the effect needs to be triggered again and new to-do items need to be fetched. Here is an example of a non-asynchronous effect. In this case, we want to manipulate the DOM, which is a side effect for React purposes. So it's not doing anything within React, and on first render it will just render the div. But if you want to create something like a modal, which should close when you click next to it, what we can do is in the effect render a event listener for the full document or any other div that you have pulled from the DOM, and register that event on it. And if you do so, if you register things outside of React, if you have event listeners or if you have timers, anything that keep on running or that may leave garbage outside of the React ecosystem, you need to clean it up yourself. React won't do that for you. And that's what we see at the end of our use effect here. It returns a new function which removes the event listener again. This function isn't called instantly. React will wait for a click example to be removed from the DOM. So if we move away to a new page or we change the state that no longer needs this component, React will remove this component from the view and it will call our use effect secondary function. So it will clean up after itself. This can be useful for removing the listeners or stopping timers or whatever you need to do whenever our component is unmounted. Going forward on manipulating the DOM or accessing things outside of React itself, we get a useRef hook, and this allows us to bind a variable to the DOM itself. And before we go any further, I think it's important to know that you should use this as a last resort. There are very good use cases to use useRef, but a lot of the times you can solve these issues within React itself, and you might need to change the way you think about your development flow a bit to get to that answer. But I would urge you to look for the solutions within React. With that out of the way, let's have a look at this example. The my component uses a ref. And useRef always starts out with a nil value. So you have to pass that as the initial state. Then we make a handle click function, a event handler. And in this case, we want to put that on the input. And we do this because we want to change or to focus that input element as soon as someone clicks on the button we also rendered. This can be useful for if there's validation issues within your form, for example. So if you would click the submit button, you could then say, oh, you didn't fill out this field just yet, and you can focus it for the end user so they can quickly change whatever they either didn't fill in or they made a mistake in their email address, for example. And this kind of flow is hard to realize within React itself. So that's where useRef comes in, and you can directly access the normal JavaScript functions you normally have and focus other input elements and stuff like that. Then there's one more thing. We have custom hooks. So we've had our hooks which are given to us by React, the use state, the use effect, and the use ref. But now we also have custom hooks. And we can use this to share code between multiple components or to your coworkers. And typically they are made of the hooks we already have from React, and we compose a new one. So we have use counter here, and we're going to do it a bit different. So we had our counter in the previous slides. We're going to make it a bit different. We're going to give this hook to our coworkers, but we want to limit how they can use it. So with our previous counter, we could also do set count of any value, or we could do count -1, so we could count backwards. Instead, what we want is that they could only increment by 1 each time. So what we do again is create our count and set count from the use state with an initial state of 0, as well as that we create a increment function that will call our set count function with the current count +1. So the same thing we had on the button. But instead of returning a tuple with the current value and a generic setter, which could set it to any value, we will return a tuple which has the same sort of look and feel, where the first value is the actual value of the current count, and the second value is our setter, which is increment, which doesn't take an argument. You can only increment by 1 each time. So with this setup, we have encapsulated our logic, and we've made sure that it can only be used in a certain way. We have limited our options, and if we share this with our colleagues or coworkers, we send a message of how to use this counter, how it can be used, how it can be utilized, and it prevents abuse in the way of that it can be set to any arbitrary value. Doing this, making this setup this way is really useful for collaborating and making sure someone doesn't break your system you've designed by only allowing them to do what they actually can do. And I'd like to land this slide on the note of hooks are not stores, which is important because if you remember, I stated that if we use the hook in one component and we use the same hook in another component, they should not share values with each other. The same is true for this use counter. If we use this use counter in two components, they will both have their individual counter. So clicking in the one component will increment it, but it will not increment it for the other component. And that should always be true, because what I've seen in some examples of code I've read is that there would be some kind of storing of data. They would, instead of use state, they would just use local data. And then by utilizing use counter, you would see that incrementing the value in one component would also increment the value in another component. And this is not what hooks are meant for, not in this sense at least, and it will confuse React on what is happening and which components to update. So please do not implement it that way. There are other ways, which we'll get to in a later module. And then there's one last slide to this module, because there are more hooks provided by React. These are use memo, use context, use reducer, use callback, and use ID. I think there's even more than that. these are not the generic hooks you're going to use in everyday development. The use state, use ref, and use effect are the three main building blocks you'll use every day, and we'll see in a lot of code bases. These are very useful, so it's good to know that they are out there, and you'll probably run into them when you need them. You'll look them up and learn about how to use them when it's needed. But until then, I don't think you'll need them, and you can leave this module without knowing anything about how they work or how they are used, and just focus on the ones we've discussed. And welcome to our fourth module of our React course, Events, where we'll talk about a powerful tool which allows us to respond to outside influences like user input or time-based events. And you might know events already from working with native HTML. There are events like onClick or onInput change. And these are available in normal HTML or plain JavaScript, just as well as we have them in React. And on top of that, React also allows you to create your custom events, which further enhance the experience or tools you'll have available to respond to whatever is happening within your UI. So how does that work? We're going to grab back to our counter component we used before, where we had the use state hook. And when we skipped over a little part of this syntax there, because if you look at the button we return, it has an onClick handler. And this looks kind of the same as our HTML, but it's slightly different. HTML would have you write it as onClick with full lowercase characters, where React typically starts in event listener with on at the start, and then a couple of keywords all capitalized with the first letter capitalized. So in this case, on and capitalized click. The other difference is that HTML would take a string value, so it would have the name of your function within the double quotes, whereas React can actually take JavaScript directly as the input of the click handler. So we do the braces to do JavaScript instead of a string value, and we pass in our anonymous function here that gets called whenever the button is clicked. And React will handle everything for you from there. There's a defining feature from the React which is called one-way data binding, which means that values passed to the DOM, to HTML, are rendered, but they're not interactive. They're not passed back to React by default. So if you have a look here at what we return, we have a form with an input field, and that input field has a value in the name, which is our local state and gets initiated with an empty string. So on first render, we have an input field with an empty value. If I were to type Bob in this field, the value of the input field would change. If I would use plain JavaScript to get the value, it will say Bob. But React hasn't been notified of this change, because as stated within our hooks course, when you directly alter the name variable, React doesn't know about it, and it will not re-render the register form, and nothing will respond to what is happening. So what we need to do is add the onChange handler, as we've done here. So each time a character is typed, when I type the B, when I type the O, and the other B again, it will call this onChange handler, which in turn will call the setName setter for our local state with the new value of that input field. So now React does know the new value and will re-render the register form with the new name variable, and will also set that value to the input field. Therefore making sure that both React and HTML are in sync with each other, and we keep track of what's happening instead of just the HTML being changed without React knowing anything about it, and we cannot act on that So this is a very important distinction to know about and to keep track of, so you keep building your applications with the correct feedback loops in place. Then we're going to move on to custom events, which are very interesting. They're more like the command pattern, if you're familiar with that, because we're not throwing events which gets picked up. We're more like telling our parent component that something has changed and that it can respond to that. They look the same as events, and we can use the same syntax. It's just that we're not passing event objects to the event handler. So how does that work? Again, we have our counter component, and if you look at the return value, it's still the same. We still have our div with the paragraph telling us how many times we've clicked, and we have our button which will up the count by 1 each time. Our local state is still the same. We start with the 0 and we have a count and set count. So what has changed is the use effect in the middle and our two new props, onReach and target. The use effect is dependent on our local state count and the target prop we've been passed. That's the array at the end of the use effect. So either of these can change. Count can change by clicking. Target can change by the parent component giving a new value to our counter component. In which case use effect will get triggered and the body will run. And what that does is check the current count against the passed target, and if they are equal, we will call this onReach function that has been passed as a prop as well. So if count and targets match, we will call onReach as if it was an event handler, and we can handle that reached event. We're going to move on to the implementation of this, or the usage actually, in the my component. So if we look at the return value, let's take a little moment here to talk a bit about React syntax, because there's two things going on here. First of all, we have these empty HTML elements wrapping our return value. And these are called fragments and are a fun component, because what it does is render no HTML at all, but it does allow you to group multiple components or elements within React. So you can use these whenever you want to do multiple things within what it looks like one component. You can wrap them in a fragment and React will happily render them for you without any additional HTML. So you don't need to do any filler divs, you don't need to do wrappers or anything. You can just use fragments instead. And the second part we need to talk about is that we have used a double ampersand here. And this allows us to do conditional rendering within React. So we have the reached value, which is a local state of which starts out with false, and we can also see we set it to true later on. So it's a Boolean value, true or false. And if a statement evaluates as false within React, it will simply not render the output of that. So what we can do here is do a Boolean value, double ampersand, and then whatever we want to render whenever the first value is true. So if reached is false, it won't render anything at all. If reached is true, it will render our paragraph that we have reached 5. And the other part of the return value is our usage of our counter component, which we had on the previous slide, which will pass on our handle reach method and our target of 5. So if we have a look again at the counter component itself, we have an event handler on reach and we have target 5. We start out with the state of 0. So when I first click the button, it will update the count value to 1. It will call the use effect. 1 doesn't equal 5, so we're not calling onReach. And we can continue doing this. So if you click again, it will say you click 2 times, count still doesn't match target, up till the count of 5, in which case it will say you clicked 5 times, count actually does equal target. So we call the onReach function that we pass here, which is handle reach. Handle reach in turn sets reached to true. This will tell React that the local state has changed and my component needs to be re-rendered. It will render reached as true, and therefore it will render our paragraph reached 5. We have now successfully combined two components with each other by using this command pattern or using a custom event without doing any hard binding to these two components. Like counter can be used anywhere else, like we can pass new handle reach functions, we can do other targets as well. And my component can just as easily use another component which also reaches something and pass the same handle reach to that other component. Custom events are very useful, and it is the way of binding components to each other without any hard binding in them. I hope you've enjoyed this module, and I'll see you in the next one. In this part, we're going to dive deeper into how to build proper components. We've been into what components are. We can add state to them and use side effects, and we also know how to handle events. And this is all good and well for building smaller applications, but it's also good to know how to make them work together and what mistakes not to make in order to build larger scale applications. There are 3 important principles that will help you guide to strong components that are reusable and will not break down when something changes. The first one is composition, and you might have heard of composition over inheritance. But the fact that we do not have inheritance in React at all, I'm just going to focus on the composition part. Then there is single responsibility, which means that each component should do one thing and it should do it well. Finally, we have uncontrolled and controlled components, which is a very important aspect of building components. And if you really grasp the concept of what uncontrolled and controlled components are, it's going to help you so much in doing proper component architecture and setting up your application in a way that you can reuse your components and that you can properly do composition. That without it, it's hard to explain all other concepts. So let's dive into that. I'm going to start off with inheritance versus composition, where we're going to have an example with dogs. So what do dogs typically do? They like to walk, they like to eat, they like to bark, they like to sleep. Those are 4 features, so to speak, what a dog can have. And what we want to build here is a normal dog, and we want to build a robot dog. So what we could do is create a base dog class or object which has the base functionalities of a normal dog. So it would eat, it would walk, and it would bark. But then if we want to build a robot dog, it cannot inherit from that dog, from that base dog, because robot dogs do not eat and they do not sleep. So either we need to build the robot dog on top of the base dog, but then remove those features again, which is going to make it very complex. Or we need to implement a base normal dog or a base living dog, so to say, and a base robot dog, which both have the same code. So if there's a bug in the one, we also need to fix it in the other, and it's going to be annoying to maintain. That's inheritance. So let's look at composition, what we have on the screen here instead. We know all the features we want to implement. So we know we want to have a drive function, we know we have a clean function, we know we have a bark function, and we're going to implement an eat function. The details of these functions are not very important for this example, but all these functions would have some contents, like drive would move the current dog forward, and bark would console log bark. Now we can build our robot dog and our normal dog just by creating a new object and putting the feature we want for that instance into that object. So in this example here, we're putting drive, clean, and bark into our robot dog, and we're going to just put eat and bark into our normal dog. So the dog and the robot dog can both bark. They both use that shared functionality if there's something wrong with it or we want it to bark differently. All we need to do is go to our bark function implementation and change it once, and all dogs we have built from this inheritance setup will use the new bark method. And so we still have that way of sharing code between objects, but we are not bound by this base object that needs to be extended and which might have things we don't like, or it might be missing things that should have been in the base. So we gain a lot of power by using composition. And this works for components just as well. But instead of creating separate functions, we're going to create smaller components that can be composed into a bigger setup that works together. Now, single responsibility is the main reason why we're going to do this. And before I move any further, I think it's good to say about this slide that this to-do list component we have over here is not a good example. Do not do this in real life, do not build this component. It's just there to illustrate why we want single responsibility. So our to-do list over here has, if I've gotten correctly, 4 responsibilities. It's keeping track of its own state. It has a side effect to fetch new to-do items. Then it has an event handler. And finally, it's rendering the actual to-do items. So rendering is also a responsibility. And that being said, a component that just renders some JSX or HTML without any logic in it is a very valid component to have in your code base. Before we're gonna fix our to-do list component, we're gonna move into that controlled component concept I've talked about before. So what we have is 2 components. We have the uncontrolled component, which is the parent, which renders the controlled component. And what we can see is that the props going in and the events going out, what we've talked about in our last module of events. So the uncontrolled component is going to tell the controlled component that it needs to render this text or this number or this list of items. And whenever something changes within that controlled component, it's going to fire this event to the uncontrolled component, which knows how to handle it and send out the new props to the controlled component. And what we want is to be, for our business logic to be in controlled components. This can be doing calculations, this can be fetching data, of all other sorts of business logic. And the controlled components is just going to wait for that input and fuse the data presented or the props being passed in the way it should show it. And this is just showing it with 2 components, but we can build this out into a whole tree of uncontrolled and controlled components working together. So back to our to-do list. We have simplified it a little, where it now gets a prop called fetched items from its parent. So somewhere on top of that is another component which does the fetching logic. We've removed that from this part. And if we want to look at why that's important, is because previously, whenever we rendered to the to-do list, it would start fetching that data itself. And by getting it from another component, from a parent component, what we can do is either have one single source of truth for the to-do item, so that top level component can fetch it and distribute it over other to-do lists. Or if we just want to keep a local copy of to-do list items, we can just create a component that creates that local list and feeds it into to-do list components straight away without any fetching at all. So that's that first line. We get a prop fetched items. Next, what we're going to do is create new local state for that fetched items, and we're just going to call it items, and we have our set items. This is important because you cannot mutate your props. It's just the same principle as with that we cannot mutate our items directly locally, because React wouldn't know that something had changed. So same thing for props. Within your component, you cannot start writing to your props because React doesn't know that it has changed. It doesn't know to re-render your component, and nothing will show on screen. So all we're doing here is just make a local copy of those fetched items in our local state items, and we have a setter to tell React we want these items to be updated and we want it to look like this. Then we have our event handler, which is gonna mutate our items. We'll get back to that later. And finally, we have our rendering, which is basically rendering a new component, the to-do item, which knows how to do the finish, which knows how to render, which knows how to render the to-do item, as well as how to determine whether the to-do item has been finished, has been done, and therefore remove it from the list. So we do our mapping here, we do a loop over all the items we have. We render a to-do item, we pass the key prop or attribute, which is important for React to match up the item in the list to the HTML rendered. Then we pass all data of that item, so the to-do item can determine what to render, what not to render, where to put it, like whether it needs to go into a H2 tag or in a paragraph. That's all the responsibility of that to-do item. Now we don't care about that at this point. What we do care about is that whenever that to-do item is finished, however that works, like if it's clicking a button or checking a box, we don't care about that part. We just want to know when it's finished, we're gonna remove it from our list, or we gotta set it to finished. So all this component now does is make sure that the to-do items are there and that they can be finished. That's the new responsibility. The data comes from outside, and the user interaction has been moved into its own component, making a neat little to-do list item component that can be reused all over your application. So with that in there, we know a bit more about how to do component architecture, and we have learned a lot about building components in a standalone fashion. Next on, we'll be moving on to building a full application by using routing, so stay tuned for that module. Routing is the concept of having different routes, or pages if you will, to your composition. And that might not make much sense within a single page application, because it's a single page, right? But within this single page, within this single thing you've served to your client, we can still make different routes, like different compositions for different states. And we can call those pages because they act similarly to how pages would work in classic web applications. And there are two options. Well, there are multiple options, but there are two common options, and those are React Router, which is a very versatile framework to allow routing in apps, allow routing in the web, but also in testing and other applications. And the other one is the one you get with Next.js. So if you've set up a Next.js application, there's already routing in place for you. And there's two basic types of routing we can use. The one is with code, and we use that through components. So we set up a router, which is a router component, and we also get the route component. So we can build the structure of multiple routes within a router, and the application will keep track of which path you are at, and will render the relevant component for that route. As you can see here, we have two routes. One is for the user's endpoint, or the user's path, and it will render the element user list. So whenever we go to that URL, it will show us the user list component. And the other one is a bit more advanced. It has the user path, and it has this colon ID special path element, and that is to get variables from your path into your components. So if you want to have the user ID in this example, we can write the path like this, and our user profile component will now get a prop called ID with the value from the URL. So this is useful for if you want to show this user, we can now fetch the user by ID and show it on our page. The other option we have here is by using a file-based routing setup, so we don't have any code. And Next.js, for example, uses file-based routing. And instead of writing the code, we now just make our file system work for us, and we can put the components we want to have rendered in those places. So we have the root pages folder. In there we have the users folder, which has the first component for the user list. And then we have the square bracket ID folder, which contains the user profile component. So this works the same way as what we see on top with the coding setup, but now we have it in our file system or in our structure, and can work with it like that, which requires less coding but makes you maintain your folder structure. So there's no good or wrong answer here. It's just a matter of flavor, choice, whatever you like to use. So like I said, a page is the root of your composition, or maybe the other way around. Like a route puts you to the root of your composition, and you can call that a page. And this is a full composition for a to-do page, which I've made here as an example. So we did the to-do list, for example, in a previous module, and we can pass in items, and we can pass in a onSelect handler. So whenever a to-do list item gets selected, we know that's the active one, and we can show that. So what I added here was a to-do viewer component, which will show that active component. So here we truly see those components working together, and where the single responsibility of each component comes into place. So instead of having one big component that does both, or even more than just the fetching of the to-do items, the viewing of the active one, the keeping track of which one is selected, and rendering the full list of to-do items. So instead we have these three different components. I'll get to to-do form later on, which are composed within our to-do page. And we can add more components here, or we can remove components. For example, we could not do the to-do list and just have the to-do viewer with a static to-do item, or a to-do item fetched from the path, as was shown before with the user ID. We could have a to-do item ID and show that one. So we have all that freedom of how to compose this page. So the last component we have on this page is the to-do form. It doesn't really matter actually what's in there. It's just an example of, we could also add a to-do form here, which runs a small form to create new to-do items, which then get added to this to-do items list. So the to-do list components start rendering that as well, and we can then click on it to trigger that handle select function, which changes local state to that new item, to that new to-do item, and views that in the to-do viewer. So they're all working together without actually having any knowledge of the other components being in place. There's a little trick you should know, or thing you should keep in mind when using routers in single page applications, because if you would use a normal anchor tag, which comes with HTML, it would start rendering, or start routing you to that actual endpoint, and that would work, but not in the way you think it would work. And it is useful for navigating to external websites, so if you want to move away from your application, the normal anchor tag will work just the way you want it. But if you do it for internal routing, it will refresh your page, it will lose local state or global state that has been defined, and it might not be the thing you want to have. Instead, most libraries like React Router and the one in Next.js offer you a special components to do this navigation for you. And typically it's called the link component, which renders an anchor tag for you and does some on-click magic. And then we can just say, oh, this link should be to, well, in this case, the user ID, and then we show the username. So if you click that link or that name, it will bring you to that page for that user ID. And instead of doing like a full navigation, like a full HTTP request to refresh your page, it will tell the router that the URL will be changed and the new page will be shown without any refreshing. So all the local state is still there, and there's no white page flashing for your end users or anything. It's a smooth way to transition to other pages. Some libraries also offer you transitions, not come to mention it. So you could do animations or other tricks there to help your user move from one page to another. So using these internal built-in components is really useful for giving the best user experience out there. So like I mentioned, we have React Router, and I guess it's the de facto third-party router out there. So if you want to grab a router, I think it even comes with Create React application. So that's the one you can go for. It has all the options you need. It's very versatile. Like I said, it can work in apps, it can work in web applications, it works in memory, so you can use it for testing as well. I don't think there's any options out there that any use cases that aren't catered for. Mostly you'll be using the browser router for web applications. So that hooks into the JavaScript history, what you call it, class. So each page you have open has this history object, which can be manipulated or can be read, so you can get the location from that. But what browser router can do for you is change the path, change the URL to something new without actually starting that navigation. So it can make sure that your URL is still the thing the end user thinks he's at or he or she is at, without doing the actual navigation. So if one would copy and paste that URL, send it to someone else, and that person would open it as well, they would to the same page, and the browser router will restore the state that's necessary to show that composition. So, and Next.js comes with its own router. Like I said, that's the file-based router. Dynamic routes are still possible, so you can still do the ID, like the path we shown before, user ID, and it will still pull that ID from the URL and feed it into your components. It just works a bit different with the file-based setup. Next.js also offers some options to fully lean into the concept of pages, where it does server-side rendering for you, and you can say that it needs certain properties being passed onto it, or that it needs to fetch data before the page can be rendered. So Next.js offers some neat tricks and features to fully build your page out, and it allows you to bypass some manual code you need to write for other routers. So that's really nice from Next.js. Go and try. This was the routing module, and I'll see you in the next one. So we've talked about local state in the past. We've used it in our counter example to keep track of the count. But we can also have application state. And this state or this data is shared between other components. So now we can have data in the one component, which is also in the other component. And this is useful for when components are not in the same hierarchy. So one component's all the way over in this tree and the other component's all the way over in that tree, but they can still share the same information. Same works for siblings, so components next to each other. We've talked about parents being able to pass props to their children and children being able to fire events back up to their parents. So we have that connection, but we don't know how to do communication between siblings themselves yet. So that's why we're going to talk about application state. Another very handy advantage of application state is to prevent what we call prop turning, where imagine we made an application and used our single responsibility architecture. So now we have like 5-7 layers of components, and the very top component has the state we need. So to bring it down to that 5th layer component, we will need to pass it to the 2nd layer, to the 3rd layer, to the 4th layer, and that's going to pass it down to the 5th layer, which can then use that data. Instead, application state can just define it globally for the whole application, and both the 1st layer and the 5th layer can access it directly. In React, we basically have two options. We can use what we call a global store, or we can use the built-in context. For the global store, there's a couple of libraries out there, with Redux being the long-running champion. But there's others out there like MobX or others, and if you look around, you'll find plenty of options for you to pick from. So if we look at our global store and have a look at this example first. So we have a store, and we have a header, we have the shop item you're going to buy, and we have these two components. One is the cart, which is showing what you're about to buy, and the other one is our Add to Cart button. So when we click this Add to Cart button, we'll need to add something to the cart. We'll need to update what's happening over there. So without any direct structure between them, like there's no relationship, there wouldn't be an option for us to pass on props from the cart to the button or the other way around. So instead, we're going to use our global store to solve this issue. So let's start with creating the store. I've used a dummy store library here because most of the stores out there use the same syntax. So it's going to be like this. Your chosen library might do it a little bit different, so look up the documentation, but it's going to be close to what we're showcasing here. So to create a store, which is done in its own file, it's not done within a component because it's not component bound. We're going to call the create store function, which has been passed from the library. And the first argument we're going to use is our initial state, our setup. So we start out with an item count of 0. We haven't bought anything yet. We are not about to buy anything. We haven't clicked any buttons, so it's going to be 0. And then we have an object with mutators, with setters. And it kind of looks like our custom hook we made for our counter earlier, where we would only allow one to increment by 1 each time. So we're going to make a new setter, which is buy item. Each setter gets the current state as an argument. And what we're going to do is return the new state, which is the item count for the current item count plus 1. So we have one more item in our basket. So then, how do we use this? We can use our new hook, our use store hook, which is the result of our create store. And as you can see, it returns an object which we can destruct, and we can get either the state itself or we can get the setters. So for the cart, we're just gonna get the item count, and we're gonna pass that on to our cart component over here. So it doesn't matter where in the application we're doing this. As long as we're using the hook, we can get access to that store and pull the item count and put it into our components. Also note that we're not doing it in the cart directly because we want to get the separation of controlled and uncontrolled components. The cart is a controlled component, so it can't do any data fetching itself. We're just passing in our item count, and the cart knows how to render it. And finally, we're going to do the buy button. And we can put that button anywhere. We can even have multiple of the same button. They're all connected to the same store, so they can all access those setters, those mutators, and change the state. Again, we use the use store, but this time instead of getting the item count from the store, we're going to get our buy item function. And we're going to render a button which will call that buy item function when clicked. Well, this buy button also takes a price, so it will render that for you, but not really relevant for the store application. So now we have it. We have a button which can be clicked. It will call buy item, which in turn mutates the global store. It will make the new state and pass that into the hooks, which will cause React to re-render our product page, which will then pass in the item count to cart, which will also re-render because there's a prop change. And now the cart shows our new item count. I mentioned prop drilling before, so if we take this example and have a look at how that would work, our product page would then know about the products available, and that would need to be passed down into the product details, then into the footer section, which goes into a call to action component, which can finally put that product information into the buy button, so the buy button can tell the store which product has been bought. If we would use a global store here, the product page could just have defined which product is currently being viewed, and the buy button would have been a direct access to that product, and there would be no prop drilling necessary at all. So that's a very handy advantage, and it saves you a lot of moving props around and defining new props on components that might not actually need that information. Like if you look at the footer section here, for example, there's no reason for the footer section to know about the product. We could have used this footer section on another page, which is not about products, and it would have this very weird, out of place prop on it, which would not be used by that page at all. The other option we have, if we're not using a global store library, we can use React's built-in context. And context is typically used for static data, for more information on what are we currently working on, or what's the theme, for example, for this section. So if we look at this example, we start out simply by creating a context, which is initiated with a nil value. And we can create a themed section component. So that's going to use the context, and it's going to render whatever children are being passed in a div which has a background color. So then if we look at our My App at the bottom, we provide the context, which is the way it's set up. You have providers and consumers. So our theme context has providers, which provide the value to all its children. And then we have the My Theme section, which is the consumer, which uses the use context hook, which gets the value from the current context. And we, as we can see, we have two providers here, one providing it with a red background and the other one providing a blue background. So we have the same component without any props telling it how to behave, but still both are gonna render in a different color. You might be wondering which tool to use for which use case. So let's have a look at that. So context is useful for, like I said, static data, like a theme. The theme won't change. So we can just say this part of the application needs to be themed as this. You can also do that at the root level, so all the page will be themed in that way. But there won't be back and forth communication between the theme and the component. So all the consumers will just read whatever theme there is at the moment and render in that color. Same thing goes for the username of a current logged in user, right? That can go into a top level application context. Other components are not going to write to it, they can just read it and render it as they see fit. And another use case would be all the merchandise that is available. So we're not going to add new merchandise on the fly. It's just there, it can be read, it can be rendered, and other things can respond to it. Well, on the other hand, the global store would write to whatever is happening. So we had our card example, which could read the merchandise from the context and then write to the global store which item has been bought or which is about to be bought. We can keep track of favorites, so if you find the clothing you like, you can favorite those t-shirts or profiles. Another fun use case is to control modals. So we can have a modal component at the very root of our application, and then we have buttons all over the place, and when clicked we can write the text we want to see in the modal to our store. And we can write a boolean which triggers whether the modal has been shown or not to the store as well, which then opens the modal with the text we've provided, and we have this control over showing the modal or not from the whole application. So we have this bottoms nodes as well. We have steering behavior for a specific section. So that's very interesting for the context part of things, is we can say we're this color now or we're that color now, as we've shown in the theme example, and we can pinpoint which parts of the application need that context. And the store is really more for communication between components, so you can do those mutations which send out a new state to other components, which will in turn respond and have that back and forward feedback loop. So we want to close off with showing a little bit more about context, about that splitting the application. In this example here, we have our blue context at the very top, which is wrapping all the components. And we have a sum component which uses the context, so it's getting rendered in blue at the moment. We've also done small and footer, which are also reading from the context and also rendering in blue. So then we have a component that's not connected, so it's not reading from the context. Not all children from a context need to actually hook into it. They don't need to use this state. So we're just having a random component in there. And then we're starting a red context. And from that point on, we're using that context instead of our top level one. So we're running the same sum component as we did in the blue context, which was then blue. But now it renders red because it's inside of the red context instead. Also note that when you use this, when you're going from blue to red context, the red context stops as soon as you're no longer a child of it. So the footer, which is below the red context but in the blue context, actually renders blue instead of red. That's it for application state, and I see you in the last module. We've looked into a lot of building components. We've looked at the basic setup, we've looked at using hooks, local state, we've got global state, we've got the right architecture and routing. So that's basically all you need to start building your application. So in this last module, we'll want to send you off with testing your application and ensuring everything works as it should work. And it gives you the confidence you need in your code base, and it gives you the reliability you want from your components, so you can start building your feature sheet like they see without the components failing on you and you have to go back and change them up or fix the issues that are in there. So tests are going to make sure that you can build and don't need to worry about issues or bugs existing in your components. There's two types of testing, or at least we're going to cover two types of testing, and those are unit testing and end-to-end testing, which is abbreviated as E2E testing. So unit testing, as the name implies, test a single unit. In the world of React, it is a single component. And end-to-end testing is testing the full application. And the story I like about around explaining unit testing and the difference between it and end-to-end testing is, for example, where you have a paper towel dispenser, an automatic one, so you can wave at it and it will dispense a paper towel for you. We can test that in isolation. We can see like, oh, I've waved, I've got a paper towel, thing is working as it should be. We can also unit test a door. A door has a handle. I can grab the handle, operate it, open the door, close the door. Door works as it should be. But if we place the door in front of the paper towel dispenser, each time I'm going to operate the door, the paper towel dispenser is going to dispense paper towels, which is not the thing we want to have. So that's where end-to-end testing comes in. It will make sure that our application is composed in such a way that all components are playing together nicely and we don't need to worry about it dispensing paper towels whenever we want to leave the bathroom. In testing, we've got two kind of people. We've got the arrange, act, and insert, and we've got the give and when, then. They're both the same thing, they're just different names for the same. And we're gonna go over these 3 phases in each test. And if you build your test this way, it's easy to read them, and you can also make sure that there's no weird side effects gonna happen. So in the arrange or given phase, we're gonna make sure that our components are rendered, that all the data is present we need to have in there, and that the stage is set. In the act and when phase, we're gonna do something. We're gonna click a button, we're gonna load to the page, we're gonna wait for the async data fetching to happen, and then finally in the assert or then phase, we're gonna look at the results and see if they match what we expected them to be. In unit test, this looks like this. Most testing libraries, by the way, start with the it function. It's globally available through your unit testing setup. So Jest, for example, would provide this function for you. You would provide the name of the test. In this case, we're going to test our counter component again. And we expect it to ups the count by 1 whenever we click on the button. So we describe what's going to happen. And then we're going to arrange our test here. So we get a render function, which is exported by a testing library. They can have different names, but typically it's render or mount. And we're going to pass in our JSX, which is just our counter component here with an initial value of 3. We get a container from it, which is our working space. And we can find our button within that container in the act phase. So the component no longer exists for testing purposes. All we have is our HTML, and we can interact with that HTML. So we'll find the button, and we can simulate a click event. So our testing framework is going to do that click in the background, and after that we're going to go into the assert phase, where we can find the paragraph where it says that the current value or the current count is 4. So we assert, we expect that whatever text content is in the paragraph, it needs to be the string 4. So this is a very simple one-off test, which tells us that if we start out with 3 and we click our button, we end up with 4. We could add more use cases in here, so we can have another it below it, which says it can go from a negative number into 0. So we start out with -1, we click the button again, and we assert that the current text is 0. So this edge cases you'll need to find and test to make sure that the component keeps acting the way it should under different circumstances. One of the options I would advise you to use is React Testing Library. I believe it uses Jest under the hood. But what it does is encourage you to test your components the way that an end user would actually interact with your component. So instead of finding a paragraph or a button in your container, a React Testing Library would more say like, oh, find this component by its text or find it by its role. So we could find a role, we could find a button that way, or a text input field. So these are roles that are defined within the W3C spec. Or we could say get by text, and if our button would say increment, we could say find any HTML element in this container by the text increment. It will return it to us, and then we could click that button. So this is more the way users interact with your web page or with your components, and therefore it's more closer to what's actually going to happen in real life. It has saved us from some bugs which weren't caused by our setup as we've shown, by really using the components as they are going to be used. We can also do component tests with end-to-end tests. So we're going to do the same counter again, and this time for end-to-end test we have no sense of what components are or what the code is. End-to-end test in some cases really open up a browser and gonna interact as if they were end users. In this case, what we want to do is go to the counter page, so page where the counter is displayed. We have this persona called Bob, and Bob is also going to click the increment button, and in which case he should see the text being 4. We are assuming here that he started out with 3, so it incremented by 1, going to 4. The great thing about test is that, well, surely you can see that one component has been tested, but you can also generate a coverage report, which is going to tell you a bit about how well a component is tested and whether it's succeeding or not. And you get this overview of all components you have and whether they're properly tested or not. And this helps us find missed branches. So if a component has conditional logic in it, if we grab back to our very first component, which rendered either hello Maarten or hey there anonymous, we could check that we could make one test for the prop Maarten. We could make one test where we don't pass a prop at all, so it would render anonymous, and then we could do another test which renders another name, and we would see it has the different welcoming text for that other name. So those are 3 branches within that same component, and if you don't test any of these branches or one of these branches, it will tell you in your coverage report that you've only tested 66% of that component, and you will need to add the 3rd test to make sure you've got the 100% coverage. It's not required to have 100% coverage, but if you're missing some coverage, you'll know that there might be edge cases that you didn't account for, which might break in real life when your application gets used in production. I also like to have coverage in my pull requests, so whenever someone changes the code, they can upload this coverage report as well, or if you're using GitHub Actions, it could automatically upload it for you. And you'll have a quick overview of what has changed and if your coverage has dropped or if your coverage has improved. So you'll know that by approving the pull request or by merging it, that something's going to change or things might not be as tested as you have wanted it to be. Typically, you can get a coverage report by either setting your CI environment variable to true or passing the -- coverage flag for your testing command. And that's all you need to know about testing your application, or at least to get started in testing your application. I hope you've learned a lot during our React course, and I wish you a happy journey in building all the cool React applications to come.
This program is presented by This.Labs, a framework-agnostic consulting firm helping enterprises realize their technical goals through staff augmentation, consulting, project management, on-demand subject experts, training, and other professional services. Find out more at This.Labs.com.